it's also brought to you by Dumb Goat Biryani.
Please don't get it.
The goats are even dumber, they're now chotia.
Chotia, oh my
Yeah.
God. People got it.
That's right, yeah. It's an inside joke.
Only
Data language, I've been integrated into the culture.
So he goes, to kind of put the context, he goes to an Indian restaurant and he says, I had dumb goat biryani. So he said, dumb goat? So no, dumb goat. So dumb is the spice that goes into a goat. And you know what biryani is, right? So instead of saying dumb, he says dumb, right? So clever, dumb, right?
He had a reasoning for it as well.
No, I think Pundalik asked me, wait, didn't you eat dumb goat biryani? And I said, no, the goat was very intelligent, Harvard educated, sharp goat. Sharp. Delicious. But they're going a different direction, they're going chotia.
Let's start.
Okay. Excuse me. All right, so who am I? I'm about to celebrate my 6th year in my career. I've been in analytics the entire time. I started out as an actuary, I'm credentialed, and now I'm just doing analytics, but I'm moving into data science now, officially as of yesterday, because my 1-year anniversary was yesterday, so the field is open.
Congratulations.
Congratulations.
Thank you. Thank you very much. Okay, data science. I'm calling it an iceberg. You'll find out why later. This is you. What? How did that happen? No. No, why did you go back? No. Yep, there we go. This is you, a lone penguin. Happy, fat, but you can swim fast. Let's get started. My service is the Predictive Kroger service. Basically, what if you could walk into a grocery store, you scan a badge, which this future is coming pretty soon with the Amazon grocery stores, and I'm fairly confident this is why they're doing it. You scan a badge, and as you're walking through the store, it's already predicted what you're going to purchase next. And it knows the location of where you're at. So the screen that you're passing by in the soda aisle says, hey, you have a high likelihood, well, it doesn't say this, but it says, hey, buy some more Dr. Pepper. You're probably out. And you're like, you know what? Oh, I am out of Dr. Pepper. How did you know that? Imagine this experience through the entire store. That's probably what's going to happen. The technology already exists. There's actually, I interviewed with a real estate company who owns a shopping center. And you don't even have to volunteer your data. They know exactly where your MAC address, they can only trace you back to your MAC address. But they know exactly where you are in their shopping center to the inch and to the second. And that data is being collected every day. You don't have to volunteer it. It just bounces off your phone and comes back. Kind of creepy. Actually really creepy. Oh, I did it again. Go back. Here was my project. My project was Instacart grocery delivery data. What?
See Beth over there.
Beth? Where do you see Beth? Oh, that was a Freudian
It's my
slip.
shopping cart?
Ah, I've got your shopping data apparently.
Wow, bananas.
Instacart grocery data, it's actually a Kaggle competition. They give you a bunch of orders that people have made. And they're asking you, of the products that you've already purchased, which ones are you going to repurchase on this next order? I thought, going into it, it was going to be all machine learning and iterating on algorithms. I thought I was going to get straight to the, let me see which algorithm works best, let me create some features. I was wrong. I literally spent about a week just staring at the problem, wondering, how do I even frame this? Which model is appropriate for this? So I'm going to open the floor. What kind of model do you think is appropriate for predicting whether or not someone's going to buy groceries or which products they're going to buy?
Hunger.
Hunger. And I mean, what I mean specifically is in the space of in the space of all the algorithms. So let's.
I was just gonna say maybe some type of unsupervised learning, so you can do some clustering.
Clustering. Okay.
Or market basket analysis.
Market basket analysis. Have you done this before?
Of course.
Here's what I'm getting at. Basically, there's two big trees of algorithms and machine learning algorithms. You can go down one or the other. You've got regression, classification. So in the most basic sense, is this a regression problem or a classification problem? Classification. Because buying or not buying is a binary event. It's a 1 and a 0. So I knew that. Like at the start of the problem, I'm like, oh, this is a classification problem. And yet it still puzzled me how to even frame the data. How to even prepare the data to put it into a model. It actually, the biggest part of this problem was, how do I think through this problem?
So how do you convert that into a single vector? Like bad into a single vector, right?
Bingo, exactly. Yeah, you've done this before, haven't you? Okay, so what we're looking at is kind of the example data. Basically, you've got a table, 33 million rows of just orders. You've got a table with product information. You've got a table with order information. You've got plenty more tables. Now they each range in size from 50,000 to 33 million rows. How do you combine all of this information into one table? How do you even feed it into a model? That's what we're going to talk about today, because that was the big problem. And Python just kept crashing. Even in the exploratory phase. It just, I did it again.
Keep hitting your arrow.
No, I don't want to see the fish. No, we don't see the fish yet.
No, there it is.
There's fish in the ocean.
Follow the arrows.
There we go. There we go. All right. We got to talk to that company about their UX. The solution, and this is pretty standard once I started thinking about it, the solution is to combine all of these tables into one table that can feed into a model. In the dumbest sense, in the most goat biryani sense, data that's fed into a classifier model has to have a row with a 1 or a 0. So let's walk through this. If I want to predict which products a person's going to rebuy, what do I need to know?
What did they buy?
If they've bought it before.
If they've bought it before.
How many
So-
they've bought before.
How much they've bought before. That's additional information, right? In the most basic sense, I need to know,
What time?
well, what time, that's additional information. I'm talking I had to slow down, take several steps back, and just what is this problem? And so what I'm saying is, how do I even create this table? And what I had to do was, I'm like, all right, okay, so I need to know what they rebuy. So this table, each row, what does one row represent? It's going to be a person and a product. And each row is going to represent the distinct lists of those person-product combinations. So if Beth buys bagels and coffee 7 times a week, and Shravan buys wine and beer 8 times a week, then you've got a table of 4 rows where 2 rows are Beth and 2 rows are Shravan. You dedupe the table. It's almost it's kind of like SQL, but it's looser than SQL. So if you're familiar with SQL, a row represents the primary key represents a distinct combination of those 3 things. But anyways, I don't want to get into the details of that. But so, it was just mind-blowing to me to even like have to rethink how I feed data into a table, because I thought, well, I've been doing SQL for 5 years, this is going to be easy. No. So, okay. So here we go. You're looking at the table right now. You've got the user ID, you've got the product ID, and you've got the label that says, this is the training data, obviously, because it's got a label. And it says 1, that this product was rebought. So there's another challenge baked into here, because when you build a model, it's not just a bunch of non-informative rows. Those rows have to have information. It was a huge challenge for me, because in the SQL world, things are very strict. Things are very like, this needs to be this needs to be this. I had no idea how I was going to join information from 8 tables. And the secret is to aggregate that information and then join. It's kind of loose, but basically what you can do is, you've got a user ID, you've got a product ID, I've got a user table, aggregate information on that user table and just join it so that I've got global user data, just columns with global user data. Same thing with products. It's not really showing, okay, here, product global data, which aisle is this product from, you know, how many times is it bought. What I concluded was, all right, the predictive model doesn't care about how the data is fed in. It just wants information. And it wants the chance to decide if that's useful information.
So the question is, what will be the next product that a user will buy? Is there a time component to it? Like, will they buy this product on a Wednesday, or just any new next product? Like, what is the question the model will eventually answer?
The question the model will answer is, basically, they're going to log in. They've ordered, they have an order history, they're going to log in. You're going to know the time, you're going to know some things about that online session. Predict which products that they've already bought that they will rebuy.
At that time.
At that time. It could be all of them, it could be none.
My question is, how fresh and how much does it cost? Did it put into consideration? How fresh my product which I'm going to buy, and how much does it cost?
That's interesting, because actually the Kaggle dataset did not include price, which is that's a big point. It didn't include price. It included basic things like which aisle did it come from, which department did it come from, and then you could generate your own basic information like of all the user data, of all the data, how many times was this product bought, but it doesn't.
No, I was just wondering, since you said session, I thought maybe you meant online only purchases, but this has aisle data in there as well. So you're talking about login as in step into the store?
I'm talking about login as session, like online session. When I said...
But then this data is for physical stores, no?
No, it's actually, so the service that this data comes from is a grocery delivery service. So all they have is an app and people that handle the logistics of getting groceries from the store to the customer. So they're never stepping in. When I say department data, I'm talking about that specific product information table.
So there's a person going in and picking it from that aisle on the shelf and putting it in a cart and delivering it to your house.
Exactly.
Okay.
And this is being piloted in San Francisco, I think.
So the only question is, what list do you give the customer to put the most desirable items at the top, maybe? So if they go bing, 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 okay, the next 12 items I don't need.
Oh, so you're saying, so what I'm hearing is, how do you pick the list of products to show?
Well, there's two things. Either the guy is going, either you've got the Amazon problem of people picking from the bins, operations problem, or you've got a marketing problem of a customer comes in and they go, oh, that's exactly what I need. And they don't have that problem of I forgot to get the milk.
I don't quite understand the question just yet, but I'll get back to it. Okay. I just want to show a couple more examples. I'm going to run through this really quick so we can get to the exciting stuff, which is the code. And now you laugh. Here's an example from my career where we had predictive models. Same thing. How do you get tons of information into one vector that you can feed into a predictive model? So this is an example of proactive care. You've got a patient, they've got thousands of rows of claims data. How do you crunch that into one row? Well, you do the same thing that you did with the grocery data. You decide what is your distinct row, you define your problem. So in this case, I want to know if my customers are at risk of developing diabetes or at risk of, it's essentially, are they at risk of becoming high cost to the company? And so this actually started out with, we've got way too many diagnosis codes. There's tens of thousands of them. How do you distill that into meaningful information? Well, unsupervised learning. Unsupervised learning. So we start with a high-cost patient data set. You apply unsupervised learning to the codes that occur in that data set. And now you've got a group of 5 groups. And those groups correspond to reality. So in the real world, those groups corresponded to, like I said, diabetes, hypertension, I think cancer was one, obesity. There's like 5 major groups. It's an example of how machine learning, reflects the real world when it's left to run on its own. Anyways.
You were saying the Instacart example can be applied to human proactive care kind of some situation.
It is, actually. This is a real example.
Okay.
I'm just using dummy data.
Okay.
But what I'm saying is the process of taking a ton of data, how do you feed that into a predictive model? Well, you define a row and you aggregate the other tables and just join on whatever column you can join on. Because the model just wants useful information. It wants a chance to decide if it's useful. It doesn't care that it's not exactly this patient, this event, this, like SQL. SQL is very strict and unforgiving, unlike Siobhan.
I'm nice.
He's very nice.
That's not offensive.
It's nice and
We'll need to run that conversation through the algorithm. Do you have a question?
So you're saying that you're going to cluster and you're basically going to put me in a group that has already got diabetes because I am now a diabetes risk. Because there's a correlation. It isn't quite perfect, but that's the group. The group that I'm in is going to be, there's a bunch of people with diabetes. Is that it?
Well, we're going to start with the high risk set. We're going to train our model. We're going to take people that we don't know that aren't high cost. So we're going to take low cost, medium cost people. Who's going to spike? And actually, the surprising thing is they weren't using, after they did unsupervised learning, they weren't using machine learning. They were using linear algebra. But essentially it was kind of like machine learning in the sense that how strongly do you score in diabetes, heart disease, obesity? And if you hit a threshold in any one of these, well, there were 5 categories, any one of these 5 categories, we've got a team that's going to reach out to you on the phone and talk to you about getting a wellness coach. And they're going to talk to you about going out and exercising if you're, I'm not sure what the solution for heart disease is. I think diabetes, obesity, maybe you get like a nutritional coach. It's really crazy because there are people at Humana in Irving right now. Their job is to, practically speaking, save lives and help people live better lives using predictive modeling. Here's another example. Let me move on. Gosh.
Keep the right arm.
Not the fish. Not the fish.
Good guy.
Okay, proactive care. Here's another example, just gonna run through it real quick. Same point. Humana had employee, how do you explain it? Employer insurance, so group insurance. You have to be a business in order to get this insurance. They've got all this data, so I was a part of the segment that was the employer insurance segment. You got all this data. I want to know month to month the people whose contracts are coming up, who's going to stay, who's going to go. Should I stay or should I go now? Okay?
Let's go.
Let's go. All right, so same thing. Same idea. But in this one, they fed the data into a projective, financial projections. So you can see, starts as a logistic regression model, because logistic because it's got, or regression because it's got,
Right.
yeah, it takes, I'm sorry, it takes real valued numbers and produces a binary classifier. Okay. God. I'm not going to need the video to this one because this is, I keep clicking on. All right, final results. XGBoost classifier. So this was getting back to the Instacart stuff. I was able to work through it and get a 300% improvement from the baseline. So here's the code. I'm just going to highlight a few things. I think 3 key things.
The things that where you spend most time,
Yeah.
where you got stuck.
Where I got stuck is one of them. That was a big problem. This is an example. This is actually started out as someone else's code. So I went on Kaggle. I had to learn how to do this. There's no documentation on how to handle big data in Python. It's not good in Google. It's very bad. So all I wanted to do was emulate this person's code. And just by emulating their code, I was able to learn a ton of things. Python crashes very easily, especially Jupyter Notebook. It crashes very easily. It runs out of memory. Very problematic. I got one step into my project, dead on the water. Found this code, amazing solutions to efficiency and memory problems. For example, just basic stuff. Specifying the data types when you're feeding in a table. That can save you 30%, that can save you, 60% in memory cost. And that in-memory cost is so precious because that's the thing that's going to crash your kernel. Carrying on. Let's see. Avoiding joins and merges at all costs. When you're talking 33 million rows, the thing's going to tank. It's just going to tank. And so what this guy did was so brilliant. Instead of trying to join 2 tables, he said, I'm going to use a basic Python object called a dictionary instead of pandas. I'm going to use pandas, but I'm going to start with a dictionary because it's so low memory. There's so many rows we're going through. We need to iterate fast. I'm going to create a new table from scratch instead of joining a table because it's too expensive to join. It'll just crash. It's just so brilliant. And I found it surprising that I was using all of these big data tools, and I went through all of the tools. I explored all of them. I had this running on the cluster. I had it running on PySpark, and it didn't solve my fundamental problem of the kernel crashing because I wasn't running on a big data. I wasn't running it on a big data stack. So if you don't have the technology backing these big data software, there's no point in using them.
Did you use AWS, Lee?
I did, yeah, several times.
And it crashed?
Yeah, yeah. Well, yeah. It would still tank. Now, granted, there are ways you can get around it. Obviously, you set up the software right, you set up your cluster right, you're going to be rocking. You don't have to worry about efficiency. But man, it just kept crashing and crashing. Now, the biggest hurdle. The most expensive, time-expensive hurdle that I ran into was I came to Shrivan after literally like 4 days straight of coding. And I'm like, there's this error, I'm doing spot checks, I have no idea what's going on. And he looked at it, and in about 5 minutes, he was like, which one is it? It's down here. In 5 minutes, he looked at the code, and he asked me, there it is. Oh God, it's traumatic even looking at it again. You think I'm joking? I spent 8 hours on this, and he's like, oh, this table name was wrong. So I think the moral of this story is never, ever code alone. And I'll just end it there. So that's my presentation.
Good job.
Yes.
So what's next?
What's next? For this project, I'd like to get on the leaderboard for Kaggle. Basically, it's kind of cool. People release scripts that put you almost like right at the top. So you release a script, it'll put you right below the top, like bronze medal. So you only have to make like a 10% improvement to get a medal on Kaggle. I thought that was cool. People share code and it pushes everybody else up. So I've got a more powerful Amazon machine. I'm gonna iterate through the algorithm. But probably more importantly is I'm gonna search for a job in data science. So I've started putting out my resume, doing that old rigmarole, tapping my connections in the data science community.
The biggest one.
All of us.
The pipeline.
All of you. Yeah.
You're an actuary and you didn't mention linear regression at all?
Linear regression as a model for this,
Just at all?
in general,
When are we all gonna die?
I'm a little, I've matured, and so I mentioned logistic regression. I've matured as an actuary. It's surprisingly, the algorithms they used at Humana for the employer group churn model, that was, like I was saying, there wasn't XGBoost, it wasn't cutting edge, it was just straight logistic regression. And in retrospect, looking back now, I'm like, huh.
So you're saying you mature